Hello. देखिए जो हमारी पिछली क्लास थी उसमें मैंने आपको बताया था व्हाट इट मींस फॉर अ फंक्शन टू बी कंटिन्यूअस ऑन द होल स्पेस. The definition is this. We say a function f acting between two metric spaces xd and yd. We say it's continuous if it is continuous, if and only if it's continuous at each point of x. Locally तो हमने पहले ही देखी थी what is this continuity. अब यहाँ in a way मैं इसको globally define कर रहा हूँ. And then we also saw its epsilon delta definition. The epsilon delta definition for continuity is this. We say it's continuous at we say a function f from xd into yd, we say it's continuous if for each x in capital X and for each epsilon positive, if there exists a delta positive. And this delta in general, it depends upon epsilon as well as the point x, such that this thing happens. ये हमने देखा था लास्ट लेक्चर में. अब यहाँ ये है कि this delta in general, it depends upon epsilon as well as the point x. Now in the case this delta depends only upon epsilon, we say the continuity is uniform. So that means for a function to be uniformly continuous, this thing should be true. For every epsilon positive, there should be a delta positive which depends only on epsilon, such that distance between fx and fu, it must be less than epsilon whenever the distance between x and u is less than delta. That means whenever x and u are delta close, their images are epsilon close. Epsilon is arbitrary, so that means मैं आपसे कह रहा हूँ कि that images of x and u, they can be made arbitrarily close by taking x and u sufficiently close. और फिर हमने ये भी देखा था what's an isometry. A mapping f acting between two metric spaces xd and yd is said to be an isometry if the distance between the images is same as the distance between the points. Distance between fx fu is same as the distance between x and u. और फिर मैंने आपको दिखाया था कि every isometry is uniformly continuous also. एक वो भी हमने देखा था. In fact, every isometry, अगर आप यहाँ देखेंगे, it must be 1-1 also. If f is an isometry, then it must be 1-1 also. और वो भी आप यहीं से देख सकते हैं, इसमें भी कोई ज़्यादा मसला नहीं है. Suppose fx is same as f of u, then the distance between fx and fu, if the points are same, the distance must be 0. But हमें ये भी पता है कि that distance between fx and fu, f being an isometry, it must be same as the distance between x and u. So saying that distance between fx and fu is 0, it amounts to saying that the distance between x and u is 0. Now the distance between x and u is 0, it implies x is equal to u. So the images are same implies the points are same. So that means if the points are not same, if x is not equal to u, then f of x cannot be equal to f of u. Because हमने देखा, if the images are same, then the points must be same. So therefore, if the points are not same, the images cannot be same. So therefore, different points have different images. So therefore, f is injective. That means F is 1 to 1. That means every isometry is injective. ठीक? Every isometry is injective. Surjectivity is not necessary for isometries. मतलब there are isometries which are not surjective. Injectivity तो होती है. If F is an isometry, then it must be injective. However, surjectivity is not necessary. उसके लिए आप एक simple example ले सकते हैं. Suppose if you consider this F from R into say 0 1, right? या ना sorry हम ऐसे करेंगे. We'll take F from zero one into R. इसे देखिए आप define it by f of x equal to x, and I'm assuming that the metric here is the usual metric, and the metric here is again the usual metric. Now if that be the case, if 0 1 is equipped with this usual metric and R is equipped with the usual metric and F is defined in this way, then F must be an isometry. Why? Because अगर आप देखेंगे distance between fx and fu, in the first place, since the metric in the codomain space is assumed to be the usual metric, so therefore this d must be actually mod of fx minus fu, right? But what is fx? Fx is same as x, so this is same as mod of x minus u. And again, since the metric in the domain space is assumed to be the usual metric, so therefore this is actually the distance between x and u, because in usual metric mod x minus u is actually the distance between x and u. So this is the distance between x and u. तो मैं आपको दिखा रहा हूँ that the distance between the images is same as the distance between the points. So therefore f is an isometry, right? But this mapping is not surjective. For example, अगर आप देखेंगे यहाँ, अगर आप यहाँ range identify करेंगे, what will be the range of f?
0 1.
Range, because the mapping is f of x equal to x, identity mapping है ना, तो the range will be, range of f is 0 1. And since clearly 2 does not belong to the 0 1, so that means there is no element in the domain of f whose image is 2. Oh, sorry, it does not. So there is no element in 0 1 whose image is 2. Clearly there is no element in 0 1 whose image under f, where fx is x. क्या कोई element है 0 1 में जिसकी image 2 है? नहीं. So therefore this mapping is not surjective. So isometry need not be surjective. However, isometry is always injective. Now, in the case your isometry, suppose there is an isometry which is surjective. हालांकि ये जरूरी नहीं है, पर मान लीजिए आप अगर इसमें surjectivity भी है, then the mapping is invertible. मैं आपसे ये कह रहा हूँ, suppose there is a mapping f from a metric space xd into a metric space yd, और मान लीजिए इस f में कुछ properties है. First property is f is an isometry, और जो दूसरी प्रॉपर्टी है इस f में, ऐसे लिखे, suppose f is a mapping from a metric space xd into a metric space yd having the following properties. The first property is that F is an isometry. The second property is F is surjective. ठीक, तो आप ये मान लीजिए। अब अभी मैंने आपको दिखाया आइसोमेट्री की एक कॉन्सिक्वेंस होती है कि फंक्शन इज इंजेक्टिव. Now you are assuming F is an isometry, so therefore it must be surjective also. As a consequence of the fact that F is an isometry, we can conclude that F is injective then. F is injective. Now F is injective, F is surjective, so therefore by these two it then follows that F is a bijection. It's a bijection means it's invertible. So therefore F inverse, it exists. Now the question is, what is this F inverse? मैं आपसे कह रहा हूं कि this F inverse, this also is an isometry. उसी को हम देखें. अब वो कैसे करेंगे आप? Let y1 comma y2 be 2 points in capital Y. Full stop. Now since ना या फिर डायरेक्टली ऐसे लिखें, नॉट सिंस, आप ऐसे लिखें. मैं यहाँ से ले रहा हूँ कि that these are 2 points in Y. यहाँ मैंने already आपको दिखाई कि that this function f inverse it exists and it will be a mapping from, ये कहाँ से कहाँ जाएगा? It will be a mapping from Y into X, right? It exists and it will be a mapping from Y into X. Now these are 2 points in Y. So अगर आप इनकी images देखेंगे under this mapping, that means अगर आप देखेंगे f inverse y1 and f inverse y2, ये किसके points होंगे? There will be points in X. ठीक? We are assuming that f is an isometry. Now these are points in X. So the distance between these 2 points will be same as the distance between their images under f, because f is an isometry. ठीक है? तो आपको ये मिलेगा. Since f is an isometry, it follows the distance between these 2 points will be same as their distance, will be same as the distance between their images under f, because f is an isometry. So ये होगा distance between f inverse y1 and f inverse y2. This will be same as the distance between their images under f. Their images under f are f of f inverse y1 and f of f inverse y2. तो ये होगा. Why? Because f is an isometry. So this must be true. Now, what is this? What's f inverse? What's f of f inverse y1?
y1.
It is y1. So this distance is actually distance between y1 and y2. तो देखिए मैं आपको क्या दिखा रहा हूँ. मैंने 2 पॉइंट्स दिए थे y1 y2 y में. मैं आपको दिखा रहा हूँ that their distance is same as their distance between their images. This distance between y1 and y2 is same as the distance between their images under the mapping f inverse. So f inverse के तहत जो इनकी जो images होंगी उनके बीच में the distance है, it's actually same as the distance between y1 and y2. So that means this mapping is also isometry. So that means inverse of an invertible isometry is again an isometry. आप नहीं कह सकते inverse of an isometry is an isometry, because in general an isometry need not be invertible. It need not be surjective. If it is surjective, that means if it is invertible, then the inverse is again isometry. तो हम यहाँ से ये देख रहे हैं. Inverse of an invertible isometry is again an isometry, right? So if you take an invertible isometry, इसका जो inverse होगा वो खुद है, वो भी एक isometry ही होगी. मैंने ये भी आपको दिखाया कि isometries are uniformly continuous. So that means if you have an invertible isometry, then इसको भी as a remark आप लिखिए. Thus, if f is an invertible isometry, तो इस f में कुछ प्रॉपर्टीज होंगी. देन पहली प्रॉपर्टी जो इस f में होगी वो ये होगी that f is a bijection. Why is this a bijection? मैं खुद ही कह रहा हूँ it's invertible. Once I say it's invertible means it's a bijection. It is same as saying that it's invertible. ठीक. और दूसरी प्रॉपर्टी जो इसमें होगी वो ये होगी कि this f is continuous. Now the question is why this is continuous. The reason that it is continuous वो ये है because it's an isometry. And isometries are uniformly continuous, so f is continuous. Third, ऊपर मैंने आपको दिखाया है if since this f is an invertible isometry, तो इसका जो inverse होगा वो खुद एक isometry होगी और therefore वो भी continuous होगी because isometries are uniformly continuous. Since f inverse in this case is an isometry, so f inverse must be uniformly continuous. So that means f inverse must be continuous. So the third property will be this: f inverse is continuous. So that means if f is an invertible isometry, तो फिर ये f एक ऐसी mapping होगी which is a bijection, which is continuous and the inverse is also continuous. और ऐसी mappings को क्या कहते हैं हम? Homeomorphism. So that means every invertible isometry is a homeomorphism. Every invertible isometry is a homeomorphism. But the converse is not true because a homeomorphism is invertible, but it need not be an isometry. There are homeomorphisms which are not isometries. So every invertible isometry is actually a homeomorphism. Is a homeomorphism, not actually is a homeomorphism. अब एक और डेफिनेशन आप लिखिए, Lipschitz maps. Let f from a metric space xt into a metric space yd be a mapping then this f is said to be a Lipschitz map if and only if we can find, or if and only if there exists this, if and only if there exists this k positive such that the distance between fx fu is less than or equal k times the distance between x comma u. And this must be true for all x's and u's in where ये कहाँ होनी चाहिए capital X. अगर ऐसा होता है if we can find a constant key for resisting happiness, then such a mapping is called a Lipschitz map. मुझे थोड़ा सा जुकाम है तो आपको मेरी कुछ वर्ड्स प्रोनाउंस करने में मुझे ना थोड़ी सी दिक्कत हो रही है. मेरी नाक से आवाज निकल रही है, तो अगर कहीं क्लियर नहीं हो रहा है तो मुझे पूछिएगा. Now let me give an example of a Lipschitz map. Before that मैं आपसे ये कहना चाहता हूँ, if f is a Lipschitz map, then you must be able to find a constant k positive for resisting this true. अब ये जो k है ना, we see this k or we call this k as a Lipschitz constant for the function. This k is called the Lipschitz constant. For the function f. That means if f is a Lipschitz map, then you must be able to find a k positive. और उस k को हम कहते हैं Lipschitz constant for f. इसकी एक सिंपलेस्ट एग्जांपल मैं आपको दे सकता हूँ ऐसे. Example of a Lipschitz map. You consider this. You consider f from metric space R with the usual metric into metric space R with the usual metric, defined by f of x equal sine of x. आप इसे देखिए. Then sin x पर हम बाद में आएंगे. फिलहाल मैं इसे भी एक सिंपल एग्जांपल लेना चाहता हूँ यहाँ पर. तो sin x भी Lipschitz होगी अगर आप ऐसे डिफाइन करेंगे, लेकिन उस पर हम बाद में आएंगे. फिलहाल आप इसे देखिए. मैं एक सिंपल एग्जांपल लेना चाहता हूँ. एफ एक्स इक्वल 6x आप लीजिए. उसको मैं इजीली दिखा सकता हूँ. फिर आप ये देखिए. देन if I ask you what is the distance between fx and fu, where x and u are some points in R, since we are using the usual metric in the codomain space, so therefore this must be mod of fx minus fu. But what is fx? Fx is 6 times x. So therefore this must be mod of 6 times x minus 6 times u. fx minus fu. 6 दोनों जगह आ रहा है, इसको आप कॉमन ले सकते हो. So this is 6 times mod of x minus u. Now again you are using the usual metric in the domain space. So mod of x minus u, because x and u are points in the domain. So mod x minus u will be actually the distance between x and u. So this is same as 6 times the distance between x and u. So therefore f is a Lipschitz map where the Lipschitz constant is 6. Therefore f is a Lipschitz map. एक और ऑब्जर्वेशन जो आप याद रखेंगे, if f from R into R is a differentiable function. If it is a differentiable function with, देखिए, I'm saying that it's a differentiable function, so I can speak of the derivative. It makes sense if I speak of the derivative. और मान लीजिए the derivative is bounded with, तो मैं मान रहा हूँ f एक differentiable function है and the derivative is bounded with bounded derivative. Then f is a ellipses map. And again, I'm assuming that the metric here is the usual metric and the metric here is the usual metric. बेहतर होता अगर मैंने ऐसे लिखा होता, मतलब explicitly. मान लीजिए ऐसे f from R with the usual metric into R with the usual metric is a differentiable function with bounded derivative. Then every such function is a ellipses map. आपको पता है इसका रीजन क्या है? Actually, why this is true? It actually follows by the Lagrange's mean value theorem. देखिए, जब आप कहते हैं कि it has a bounded derivative, so that means it means this. It means f dash x in the modulus, it must be less or equal to k, and this must be true for all x's in R. है ना? Because you are saying that it has a bounded derivative, so therefore ये होना चाहिए. अब आप क्या करिए? Let's take 2 points, x and u in R, which is our domain. ठीक है? You are given that f is differentiable. It's differentiable mapping from R. It's differentiable on R, so therefore it must be differentiable between x and u. In the first place, when I say this is differentiable in R, it means it's continuous in R because every differentiable is continuous. So therefore it's continuous in R. So in particular, it must be continuous on the closed interval xu, right? It must be continuous on the closed xu. Also, it must be differentiable in the open interval xu. Why? Because it's differentiable in R. Once it's differentiable in R, it must be differentiable in every part of R. Right? Not actually in every part, but at least on intervals. Now xu is an interval, so it must be differentiable in xu. So therefore, it satisfies all the conditions for the Lagrange's. It satisfies all the requirements of Lagrange's mean value theorem. So therefore, fx, fu minus fx, this must be equal to u minus x times f dash of c, where c is some point between x and u. तो ये होगा. So therefore, mod of f of u minus f of x will be mod of u minus x times f dash c, and this is equal to mod of u minus x times mod of f dash c. Now mod of f dash c is less or equal to k because we know that f dash is bounded, and so therefore mod f dash x will be less or equal to k for कोई ना कोई ऐसा k होगा, k पॉजिटिव होगा जिसके लिए ये हो रहा होगा. So if I use this, आपको ये मिलेगा फिर. Therefore, now since you are using the usual metric, so therefore in terms of usual metric, this can be written as d of f of u, f of x assuming that d is the usual metric. So and और आप कह रहे हैं कि that this is equal d of mod u minus x, it can be written as d of u comma x, then times mod f dash c. Now mod f dash c is less or equal to k, so overall this is less or equal to k times d of u comma x. So distance between the images of u and x is less than or equal to k times the distance between u and x. So therefore it is a Lipschitz map where k is the Lipschitz constant. So मैंने ये justify किया कि that every differentiable function with a bounded derivative is a Lipschitz map. So in particular अगर आप इसे आप देखेंगे sin x को fx equal to sin x, this is also a Lipschitz map. Why? Because इसका जो derivative है it's differentiable sin x जो है ना it is differentiable. Furthermore अगर आप derivative पर आएंगे f dash x, derivative of sin is cosine x, and mod of f dash x will be mod of cosine x, and since we know that mod cosine x it cannot exceed 1, so therefore it's less or equal to 1. So therefore this f is differentiable and has a bounded derivative. So therefore by this observation यहाँ देखिए it must be a Lipschitz map. So fx equal sin x is a Lipschitz map. fx equal to cosine x is also a Lipschitz map. Because cosine का जो derivative आप लेंगे, जब आप derivative लेंगे it will be minus sign, and minus sign is again bounded. So every differentiable function which has a bounded derivative is a Lipschitz map. Provided you use the usual metric, है ना, ये सारा कुछ मैं आप ये तब justify कर सकते हैं when you are using the usual metric. That is important. These are some examples of these Lipschitz maps. अब आप in fact खुद भी examples create कर सकते हैं अगर बस आपको इस चीज़ का ख्याल रखना है. You have to use usual metrics and you have to take functions which are differentiable with a bounded derivative. अब Lipschitz map में जो Lipschitz constant होता है k. Now if this k, if it happens to be strictly less than 1, ये जो Lipschitz constant है ना यहाँ, if f is a Lipschitz map, तो ये constant होगा ना k. Now if this Lipschitz constant, मतलब अगर एक और additional property है किसी Lipschitz map में, that the Lipschitz constant k is strictly less than 1, then the mapping is said to be a contraction. अब इसे आप लिखिए contraction. Let f from xd into yd, metric space yd, be a mapping, then f is said to be a contraction if and only if there exists a key with, एक तो ये पॉजिटिव होना चाहिए 0 लेस देन k और स्ट्रिक्टली लेस देन 1 होना चाहिए. Actually it's said to be, अगर ऐसा if k is strictly less than 1, we say it's a strict contraction. तो आप यहाँ लिखिए वो, it's said to be a strict contraction. It's said to be a strict contraction if and only if there exists a k with 0 less than k, strictly less than k, and k is strictly less than 1, such that the distance between fx, fu is less than or equal to k times the distance between x and u, and this must be true for all x's and u's in capital X. तो अगर आप यहाँ से देखेंगे ना, strict contraction is simply a Lipschitz map because this is precisely what is required for a mapping to be a Lipschitz map. So a strict contraction is a Lipschitz map where the Lipschitz constant is strictly less than 1. Now can you give me an example of a contraction? अगर आप इसे देखेंगे fx equal 1 by 2 times x, assuming that f acts from or it acts between r with the usual metric and goes into r with the usual metric. अगर आप इस फंक्शन को देखेंगे, then distance between fx fu, since d is the usual metric, and this will be because we are using the usual metric in the codomain space, so this must be mod of fx minus fu. Now fx is 1 by 2 times x, this will be mod of 1 by 2 times x minus fu, which will be 1 by 2 times u. 1 by 2 दोनों जगह आ रहा है, so this will be 1 by 2 times mod of x minus u. So this is further equal to 1 by 2 times mod of x minus u can be written as distance between x and u, because of domain space में भी usual metric use कर रहे हैं. तो मैं आपको दिखा रहा हूँ that distance between fx fu is equal to 1 by 2 times the distance between x and u. So therefore it's a contraction because यहाँ जो Lipschitz constant आपको आ रहा है it's 1 by 2 and 1 by 2 is strictly less than 1, so it's a contraction. अब इसको contraction क्यों कहा जाता है, यहाँ आप इसको ना देख भी सकते हैं. For example, अगर आप लेंगे, if you take this interval 0 2, closed interval 0 2. Now if I ask you what is the image of this interval under this mapping, what will be the image? Image means आपको इस interval के हर एक point पर f apply करना है.
Close 0,1.
It will be closed at 0,1. So that means ये जो mapping है it transforms closed at 0 to किस में transform करती है इसको into closed 0 1. अब अगर आप इन दो को compare करेंगे ना, what is the relationship between this and this interval?
Subset 0,1 is subset.
Subset है, लेकिन आप इसको एक different तरीके से भी कह सकते हैं. यहाँ पर you can say that this is a contraction of this.
Yes, sir.
0 1 is a contraction of 0 2, and where the contraction factor is, आप बता सकते हैं what is the contraction factor?
1 by 2.
1 by 2.
This precisely this Lipschitz constant जो आप यहाँ देख रहे हैं ना, because यहाँ we have equality, d of x fx fu is equal to 1 by 2 times, so this is precisely the contraction factor. अब this मैं आपके लिए एक एग्जांपल एक एक्सरसाइज छोड़ रहा हूँ, आप दिखाइएगा कि every Lipschitz map is uniformly continuous. ठीक है, the moment you show that every Lipschitz map is uniformly continuous, it then follows every contraction is also uniformly continuous. Why? ऐसा क्यों होगा? Because every contraction is a Lipschitz map, so if every Lipschitz is uniformly continuous, it follows every contraction is also uniformly continuous. So this is an exercise for you, इसको करिएगा आप. Show that every ellipses map acting between two metric spaces xt and yt is uniformly continuous. इसको ट्राई करिएगा. It follows directly from the definition of ellipses map है ना. ये जो है ना, आपको ज्यादा कुछ नहीं करना. You simply use the definition और वहीं से आप देख सकते हैं कि that every ellipses map is uniformly continuous, and therefore it then follows that every contraction is also uniformly continuous because every contraction is a ellipses map in the first place. ये मैं आपके लिए एक्सरसाइज छोड़ रहा हूँ. अभी कितना टाइम है हमारी क्लास में?
सर 5 मिनट.
तो जो मैं करना चाहता हूँ वो तो नहीं हो पाएगा अभी. चलिए ठीक है, ये काफी आप आज के लिए.
हो गया अभी दूसरी क्लास.
सॉरी
सर अभी 12 बजे हमारी दूसरी क्लास भी ना सर.
ठीक है. मुझे ये बताइए, आप कोई अगर क्वेश्चन वगैरह है तो आप ये 2-3 मिनट उसी में हम फिर कंज्यूम करेंगे. अगर कोई क्वेश्चन वगैरह है तो पूछिए आप.
सर ये जो ellipses कांस्टेंट है ना,
हाँ,
ये मतलब मोर देन 1 हो सकता है?
क्यों नहीं हो सकता? मैंने अभी एक एग्जांपल दी ना आपको,
6.
इसमें वो 6 आया था.
यस सर, उसमें 7 भी ले सकते हैं.
अगर 7 ले, अगर आपने मैपिंग ली होगी, सपोज fx equal to 8x, in that case ellipses constant will be 8. There is no uniqueness to this ellipses constant. ये भी याद रखिएगा, if k is a ellipses constant, suppose k is a ellipses constant for a function f, say, ठीक, then any number, then any k1 which is bigger than k is also a ellipses constant. Is also ellipses constant for the function f. Why? Because अगर k के लिए ये हो रहा है, that means ये होगा फिर fx. अगर if k is ellipses constant, so therefore fx, distance between fx fu, this will be less or equal to k times the distance between x comma u, right? Because k is ellipses constant. Now k1 is strictly greater than k, so this must be strictly less than k1 times the distance between x and u. अब अगर आप इसे देखेंगे, अगर आप इस बीच वाले को डिस्कार्ड करेंगे, दैट मीन्स आप अगर ये रिटेन करेंगे, दैट डिस्टेंस बिटवीन fx fu is strictly less than k1 times the distance between x and u, यहाँ से फॉलो होता है कि that k1 is also ellipses constant. वही मैं कह रहा हूँ आपसे, if k is ellipses constant then every number greater than k is again ellipses constant. तो यहाँ से तो क्लियरली फिर ये फॉलो होता है कि that ellipses constant can be greater than 1 also. In fact it can be greater than any quantity, because फिर जो मैं यहाँ कह रहा हूँ ना आपसे, if k is ellipses constant then every number greater than k is again ellipses constant. अब इस k1 पर तो कोई हद नहीं है, it's unrestricted. That is the reason we say a ellipses constant. I'm not saying the ellipses constant. मैं कह रहा हूँ a ellipses constant.
सर
हाँ बोलिए।
सर जो हमने कंट्रैक्शन पढ़ा ना सर,
हाँ
ये मैप, तो इसमें हम जो के ले रहे हैं लिपचीज कांस्टेंट,
ठीक
हम 1 से लेस ले रहे हैं सर,
ठीक
0 से ग्रेटर।
ठीक।
तो हम ये कह सकते हैं, इसका मतलब ये है कि जो हम पॉइंट्स ले रहे हैं उनके बीच जो डिस्टेंस होगी,
हाँ
तो वो ज्यादा होगी जो उनकी इमेज होगी,
मतलब
उनके
आप
बीच जो
कह
डिस्टेंस
सकते
उससे।
हैं कि द मोमेंट यू ट्रांसफॉर्म दोज पॉइंट्स यूजिंग योर मैपिंग, जो इमेजेस आती है फिर इवेंचुअली बिटवीन द इमेजेस, वो कम
जी सर।
होगी।
तो
इसीलिए तो इसको कंट्रैक्शन कहते हैं ना हम।
जी सर।
मतलब आपने
तो
आपके पास इनिशियली पॉइंट्स है एक्स एंड सपोज एक्स एंड यू।
जी सर।
ये देखिए आप उस इस तरह से आप ना एक फिगर बनाइए। सपोज दिस इज योर डोमेन स्पेस और ये मान लीजिए आपकी कोडोमेन स्पेस, and suppose there is a contraction acting between these two spaces, and now let's take 2 points x and u, ठीक। और मान लीजिए this is the image of fx, oh sorry, this is the image of x, and this is the image of point u, that means this is f of u. Now if this f is a contraction, then there must be a c such that 0 is strictly less than c is strictly less than 1, and the distance between fx and fu, this will be less or equal to c times the distance between x and u. Now the distance between x and u, sorry, this c times the distance between x and u, since c is strictly less than 1, because c jana, it is strictly less than 1, so therefore c times the distance will be less than or equal the distance between x and u. आप बता
यस
सकते
सर।
हैं मैं यहाँ less or equal to क्यों ले रहा हूँ? Although c is strictly less than 1, but still I am taking less or equal, because I don't know whether this is पॉजिटिव और नॉट। अगर ये जीरो होगा तो इक्वालिटी ही रहेगी। अगर ये डिस्टेंस जो है ना, अगर इफ दिस डिस्टेंस इज जीरो तो यहाँ इक्वालिटी ही रहेगी। हाँ, इफ इट इज पॉजिटिव देन देयर द इनइक्वालिटी विल बी स्ट्रिक्ट। तो अब अगर आप इसे यहाँ इंटरप्रेट करेंगे ना, आप क्या कह रहे हैं? यू आर सेइंग द डिस्टेंस बिटवीन द इमेजेस इज लेस देन और इक्वल द डिस्टेंस बिटवीन द ओरिजिनल पॉइंट्स। तो दैट मीन्स जो ट्रांसफॉर्म करके जो आपको नए पॉइंट्स मिले थे उनके बीच में जो डिस्टेंस है वो इनिशियल डिस्टेंस से कम है। And this
जी
again
सर।
justifies the fact that f is a contraction. It contracts points.
तो आइसोमेट्री के साथ सर हम इसको रिलेट कर सकते हैं, फिर ये आइसोमेट्री
आइसोमेट्री
नहीं
में
है।
कहाँ इसको रिलेट कर सकते हैं? आइसोमेट्री में डिस्टेंसेस आर प्रिजर्व्ड।
जी
वहाँ
सर,
ये
मतलब
होता है
ये नहीं होगा कभी आइसोमेट्री सर।
कहाँ हो सकती है? यहाँ आप
जी सर।
पहली जो कंडीशन है यहाँ पर दिस c it is strictly less than 1. So there
यस
is a
सर।
contraction here. So distances are not preserved. देखिए एक तरफ से मैं कह रहा हूँ c is strictly less than 1. So that means यहाँ contraction हो रही है। So it cannot be an isometry. Isometry में distances are preserved. Isometry में distance
सर
between fx and fu is equal to the distance between x and u. So therefore the distances are preserved. ये जो mapping है f, it does not disturb the distances if it is an isometry. Whereas in contraction, we have a contraction. Contraction is happening there. So a contraction cannot be an isometry.
सर आइसोमेट्री को बोल सकते हैं लिपशीज मैप?
Isometry is a ellipses map, हाँ। अब ये तो डेफिनेशन से ही समझ आता है ना, बिकॉज फॉर अ मैपिंग टू बी अ ellipses मैप द रिक्वायरमेंट इज दिस इज द रिक्वायरमेंट fx fu मस्ट बी लेस और, यहाँ है ना लेस और इक्वल टू, दैट मींस इक्वल टू भी हो सकता है, लेस और इक्वल टू k टाइम्स d ऑफ x, u. सो क्लियरली आइसोमेट्री इज अ ellipses मैप, बिकॉज आइसोमेट्री में ये होता है fx fu is equal to the distance between x and u. बिकॉज अगर आप यहाँ k लेंगे 1 और यहाँ अगर आप, सिंस यहाँ है ना एक पॉसिबिलिटी इक्वालिटी की भी, मतलब इफ इट इज इक्वल तो उस केस में भी इट्स ellipses मैप, अब अगर वैसा हो रहा है, इफ दिस k is 1 और यहाँ इक्वालिटी है, it becomes a criteria for isometry. So therefore every isometry is a ellipses map. चलिए ठीक है, फिर ये काफी आज के लिए। मुझे एक और बात आपसे कहनी थी, ये मैं ऑन रिकॉर्ड कह रहा हूँ, वहां से रिकॉर्डिंग भी हो रही है। मैं मतलब मैं जानबूझकर इस चीज को ऑन रिकॉर्ड कह रहा हूँ। मैं आपको ना क्लोजली मॉनिटर कर रहा हूँ, आपकी अटेंडेंस को। आपकी क्लास का जो रोल है वो नियर अबाउट 50 के अराउंड है। आप 45 to 50 होंगे आप, क्योंकि कुछ नए स्टूडेंट्स भी आए थे और कुछ ने ड्रॉप किया था, तो मुझे एग्जैक्ट फिगर का नहीं पता है अभी। बट स्टिल जो मैं देख रहा हूँ ना, पर डे कम से कम 14 to 15 स्टूडेंट्स एब्सेंट होते हैं ऑन एवरेज। मैं कह रहा हूँ, मैं कल को कोई उनकी गारंटी नहीं लूंगा। मतलब अगर वो फेल भी होते हैं ना, आई एम नॉट रिस्पॉन्सिबल, बिकॉज अगर वो क्लास में नहीं आता है और फिर वो अगर वो क्वालिफाई करता है टेस्ट, सो दैट मीन्स वो सिस्टम की प्रॉब्लम है। एक ऐसा स्टूडेंट जिसको पता ही नहीं है सिलेबस का, जिसको क्लासेस का पता नहीं है, और फिर भी अगर वो एग्जामिनेशन में अपीयर होता है और फिर क्वालिफाई कर जाता है, मीन्स वो सिस्टम की प्रॉब्लम है। तो ऐसे स्टूडेंट्स एक्चुअली डिजर्व नहीं करते हैं क्वालिफाई करना। तो अगर वो कल को फेल भी होंगे ना, आई एम नॉट रिस्पॉन्सिबल, मैं ये ऑन रिकॉर्ड कह रहा हूँ। और ना ही कल को मुझे वो कह सकते हैं कि हमें समझ नहीं आता है। समझ कहाँ से आएगा जब वो क्लास ही में नहीं आए? तो मैं आपकी अभी एक तरह से समझ लीजिए, मैं आपकी वो बुनियाद बना रहा हूँ जिसके बेस पर आप फिर आगे इसमें चल सकते हैं। अब जब आपकी पहली आपकी फाउंडेशन ही कमजोर होगी, तो आगे जो इमारत बनेगी उसके ऊपर वो ऑब्वियसली तो वो तो फूक से फिर उठ जाएगी। उसका ख्याल रखिएगा, उनको कन्वे करिएगा अगर आपका कांटेक्ट है कोई उनके साथ। चलिए ठीक है, आप जा सकते हैं।